In this video, we're going to go over the definition of work and solve some practice problems. The short definition of work is a transfer of energy to or from an object by applying a force. There are two types of work: positive work and negative work. Positive work is the transfer of energy to the object, and negative work is the transfer of energy from the object. In other words, positive work means the system is receiving energy from its surroundings, and negative work means the system is giving energy to its surroundings. And we can use the formula W equals FD cosine theta to find the amount of work done on the object, where W is work, F is the magnitude of the force, D is displacement, and theta is the angle in degrees between the work and force vector. And we can find the total work done on an object by adding all the work components together. Now that we have an idea what work is, let's do some practice problems. Let's say you pulled a box that weighed 5 newtons to the right across the floor. You pull the box 10 meters with a force of 20 newtons. And let's say there was a kinetic force of friction of 7 newtons. And we want to find the work for all the force components acting on the box. So first, let's draw the free body diagram of the box. So we will have our force of tension pointed to the right, and that's going to equal 20 newtons. We will have our force of friction pointed to the left, and that's going to equal 7 newtons. We will have our gravitational force pointed downward, and that's going to equal 5 newtons. And lastly, we'll have our normal force pointed upward, and that's also going to equal 5 newtons. And let's also write down the direction of our displacement, because that's going to be helpful for later on. Now that we identified all the forces acting on our box, we can use the formula FD cosine theta to find the work done by each of these force components. So the work done by the tension force is going to equal the magnitude of the force, which is 20 newtons, times the displacement of the object, which is 10 meters, times cosine of the angle between the force vector and the displacement vector. And we see that the force of tension is in the same direction as the displacement vector. So the angle between these two vectors is 0. And we know that the cosine of 0 is equal to 1. So that means the work done by the tension force is going to equal positive 200 joules. Now let's solve for the work done by the friction force. So the work done by the friction force is going to equal the force of friction, which is 7 newtons, times the displacement of the object, which is 10 meters, times cosine of the angle between the force of friction and the displacement vector. And we see that the angle between these two vectors is 180 degrees, because they're both pointed in the opposite direction. So we will have cosine of 180. And we know that cosine of 180 is negative 1. So the work done by the friction force is going to equal negative 70 joules. Now let's solve for the work done by the gravitational force. So the work done by the gravitational force is going to equal the magnitude of the force of gravity, which is 5 newtons, times the displacement, which is 10 meters, times the cosine of the angle between the two vectors. And we see that the angle between the displacement vector and the force of gravity vector is 270 degrees. And we know that cosine of 270 is 0. So the work done by the gravitational force is going to equal 0 joules. Similarly, if we were to calculate the work done by the normal force, we will see that the angle between the displacement vector and the normal force vector is equal to 90 degrees. And we know the cosine of 90 is 0. So the work done by the normal force is going to equal 0 joules. And if we were asked to calculate the net work, then we would just add all of these components together. So in this case, the net work will equal 200 joules minus 70 joules plus 0 joules plus 0 joules. And this will give us a total of positive 130 joules. Now let's look at another problem. Here we have two problems. In the first problem, let's say we exerted exactly 500 newtons to raise the weights above our head 2 meters above the ground. And we want to know how much work was done. Well, first, let's draw a free body diagram. We know that the direction of the force is going to be pointed upward, and that the displacement is also going to be upward. Now that we know this, let's plug in what we know into the formula. So we have the work is equal to the magnitude of the force, which is 500 newtons, times the displacement, which is 2 meters, times the cosine of the angle between the force vector and the displacement vector. And since they're pointed in the same direction, the angle between these two vectors is 0. And we know that cosine of 0 is 1. So the work done is equal to positive 1000 joules. Now let's do the second problem. In the second problem, let's say you're holding a box steadily in your hands and it weighed 2 newtons and you traveled 5 meters to the right. And we want to know how much work has been done. Well, first we have to draw the free body diagram. So the direction of the force is in the upward direction because you're keeping the box from falling to the ground. And the displacement of the box is to the right. Now that we know this, let's plug in what we know into the formula. So the work is going to equal the magnitude of the force, which is 2 newtons since you're keeping it steadily in your hands, times the displacement, which is 5 meters, times the cosine of the angle between the force vector and the displacement vector. And we see that the angle between these two vectors is 90 degrees. And we know the cosine of 90 is 0. So the work done is equal to 0 joules. So one piece of advice is to always draw your free body diagrams so that you don't get the wrong angle between your force vector and your displacement vector. So in recap, work is the transfer of energy to or from an object by applying a force. And there are two types of work: positive work and negative work. And the formula we were given is work equals the magnitude of the force applied on the object times the displacement of the object times the cosine of the angle between the force vector and the displacement vector. And to find the net work, we would just add all the work components together. Thank you for watching this video and hope to see you next time.